Hello to everyone watching this video. Today's video is about a general introduction to soil and foundation engineering, like a general overview of what it is. So let's begin. The branch of science that deals with the study of soil, its behavior and application as a engineering material is known as a soil. First of all, this word soil has been derived from the Latin word solium, which means the upper layer of the earth that may be dug or plowed. And in terms of engineering, soil is defined as unconsolidated material, like which could be used or which first of all is formed by the disintegration of soils and is composed of solid particles. Soil also contains a void space between it, which might contain air, water, or both. Okay, the solid particles that the soil contains is mainly composed of organic matter. First and the foremost question that arises is how this soil is formed. Soil is formed due to the weathering of the rocks. What is weathering, you might ask? Weathering means the disintegration, that is the टूटना जिसको आप बोल सकते हो, of the rocks. Now it could be due to the two reasons: due to physical weathering, due to physical disintegration, or due to the chemical weathering, that is a chemical disintegration. Now the physical disintegration or the mechanical weathering of the rocks can be occurred due to the following reasons: due to the change in temperature, that is the heat, or the rain or snow, say there's a frost action. Chemical disintegration occurs due to hydration, carbonation, oxidation, hydrolysis, solution forming, etc. Now, soil may be residual or transport. Residual soil means it is located at the place of weathering or origin, or you could understand it in a way that the soil that stays at its own place, that is the formation of the parent rock, where it is formed, when it stays over there only, then it is known as a residual soil. And whereas when the soil gets redeposited by the agencies like wind, water, ice, that is, it is transported from one place to another, then it is known as transported soil. Now the classification of the transported soil is as follows: alluvial, marine, aeolian, lacustrine, and glacial. Alluvial soil is majorly found in the North India, and it refers to the transported soil that is deposited along the stream. Now, marine soil. This type of soil is transported by when a stream meets a sea. Now the aeolian soil is when the wind blows and transports the type of soil. It refers to aeolian soil, that is preferably sand. Now the next type of soil is the fine grained soil that is transported by the water and is deposited at the bottom of the lakes. Now the glacial soil, as the name suggests, it is formed by the glacial water, or is redeposited by the glacial water. Okay, now moving on. Special types of soil, the first one being the bentonite. The bentonite clay is the clay which has a very high percentage of clay mineral, montmorillonite. It is a very highly plastic clay. Now it results from the decomposition of the volcanic ash. Okay, it is highly water absorbent and has a high shrinkage and swelling characteristics. Now moving on, the next one being the cobble. Now the cobbles are large size particles whose range is from 80 mm to 300 mm. Now the next one is boulder. The boulder refers to those rocks that are 300 mm, whose size is greater than 300 mm. Now muck. Muck is black in color and it is avoided for the engineering works as it is organic matter. So when we like try to like construct tunnels, then this type of soil is like obtained during the construction of tunnels, and it is highly organic in nature, but we cannot use it for like engineering purposes. Now the next one being the fills. Fills are the man-made deposits of soil and waste materials, and these are known as fills. Whenever we have to fill something, like their engineering properties depends upon the type of soil, their water content, and the degree of compaction. Now moving on, the next topic is the properties of soil. Now the properties of soils could be discussed and like explained on the basis of a phase diagram. Now the phase diagram is a systematic representation of the natural constituents of the soil, known as a phase diagram. Now the physical properties of the soil can be measured by two ways: by volume and by weight. By volume, now also it has three like major components, and that are being air, water and soil. The soil is a three-phase system, but it becomes two-phase system in the case when we like discuss it. So the soil is a three-phase system, but it becomes a two-phase system when in two cases: when the soil is absolutely dry, that is there's no water at all, or when it's fully saturated, that is there's no air at all. Okay, phase diagram is the real representation of the real soil. Okay, now in case of like the volume, physical properties of the soil can be discussed in or like measured in three like major types. First of all, it's the volumetric properties, then the weight properties, then the weight volume properties. In the volume properties, the first that we discuss is the void ratio, then the porosity, then the degree of saturation and the air content. In weight properties, it's the moisture content. Then coming on to the third type of the physical properties that we will discuss is the weight volume relationships. It under that will cover the bulk unit weight, dry unit weight, saturated unit weight, submerged unit weight and the buoyant unit weight. And we'll continue in the next video. Bye. Subscribe.